Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are solving April 2019 University question paper under the subject Operation Research. This is the part 3 of our video series, okay, based on solving this particular paper. So let us see which are the questions that we are going to take up in this particular video. The very first question was question number 3A. 6 jobs have been processed in 3 machines. So now there's a job sequence with 3 machines. Okay, you are given the time of each job. Find the sequence that minimizes the total elapsed time. Calculate the total elapsed time and find the idle time of A, B, and C. Now, whenever 3 machines are given, remember you have to first combine, A, B, and B, C, and make it into 2 machines. So we are going to add A and B and B and C and make it into G and H. Okay, so it will be considered as machine G and machine H. Okay, so 12 plus 3, 8 plus 4, 7 plus 2, 11 plus 5, 10 plus 2, and 5 plus 4. That becomes your machine G. And B and C, when you add 3 plus 7, 4 plus 10, 2 plus 9, and so on, and we'll get a H machine. Now from this we need to find our job sequence. So job sequence would have been the lowest value is 8, which is under job H, machine number 6, so it came here. Next lowest comes to 9, which is under machine 3 under G, so it came on G side. Next is 11, which is under which is under machine H. Okay, so wait, I'll just note down this one. Next is 12, which is under G. Then we have again 12, which is under. Okay, then we had 10. Okay, before 11, we have 10, which came here. And then we had 11, which is here. So our job sequence is 3, 2, 5, 4, 1, and 6. Okay. Once we get that, now we need to make a table where we'll have job sequence, we'll have machine A, machine B, and machine C with in time and out time. So this is how it should look. We start with machine A. We noted down the job sequence. We noted down 0. We started with 0. So 0 plus the value of. Now we have to look at. Now this is over. This part is done. So now we again have to look at here. The third job ka R was 7. So 0 plus 7 is 7. Then 7 plus second is 8. So 7 plus 8, 15. 15 plus 10, 25. 25 plus 11, 36. 36 plus 12, 48. And 48 plus 5, 53. Now out time of A is in time of B. We start from 7. Then 7 plus the third job timing is 2. So 7 plus 2, 9. 9 and 15 may 15 is greater. So we start with 15. 15 plus 4, 19. 25 is greater. We start with 25 plus 2, 27. 36 is greater. 36 plus 5, 41. 48 is greater. 48 plus 3, 51. And 53 is greater. 53 plus 4, 57. Same way out time of B is in time of C. So 9 plus 9, 18. 19 is greater, so 19 plus 10, 29. 29 is greater, 29 comes here. 29 plus 11, 40. 41 is greater, so we start with 41. 41 plus 6 is 47. 47 and 51 51 is greater. 51 plus 7 is 58. 58 comes down, and 58 plus 4, 62. Once we get that, we need to now note down the total elapsed time, which comes to 62. Okay, so total elapsed is 62 hours. Idle time of A will be 62 minus 53, which comes to 9 hours. Okay, same way for B, 62 minus, okay, B ka processing time, that is 2 plus 4 plus 2 plus 5 plus 3 plus 4, which comes to 20. So minus, you get it 42. And last for C, 62 minus C ka processing time, that is 9 plus 10 plus 11 plus 6 plus 7 plus 4, which comes to 47. When you minus, you get it at 15. Okay, so this is how you'll have to solve the third one. I mean 3A, which are job sequence with 3 machine. I hope everyone have understood that. We jump to the next one. Question 3B. Now this is based on, they're giving you activity node, optimistic time, most likely time, pessimistic time. Draw a network diagram. Find the expected time of the project completion around with standard deviation, and what is the probability of the job to complete in 55 days. So now for this, we need to find the estimated or expected time and variance, because we need those two columns. So activity we have noted down node. We need to find expected time, which is A plus 4M plus B. Now this is A, this is M, and this is B. Okay, so 4 plus A plus 4 into M plus B. So 4 plus 4 into 6 plus 8 divided by 6. That's the formula. So we get the expected time. So the first expected time is 6. Then 8, 8, 18, 10, 8, 2 and 7. Okay, we are using the formula A plus 4m plus B upon 6. Then we need to find variance, that is B minus A. Okay, so your B is 8 minus 4, which is 4 upon 6. So 4 4s are 16, 6 6 are 36. So we get a variance 16 upon 36, 10 upon 36, 64 upon 36, 256 upon 36, 64 upon 36, 64 upon 36, 4 upon 36 and 4 upon 36. Now with the activity, with the node and with the expected time, we can make a network diagram. So a network diagram should look like this. Okay, we have 1 and 2 with A, then 2 and 3 with B, 2 and 4 with C, then 3 and 5 with D, 4 and 6 with E, 5 and 7 and 6 and 7 they merge, so F and G merge and they become H, which is 8. The time for which is given here, we found A ka it is 6 hours, then 6 days, then 8 days, 8, for D it is 18, E 10, uh, F is 8, G is 2 and H is 7 hours. Okay, so we got that. We got the critical part. So our critical part will be A, B, D, F, H or A, C, E, G, H. The time of 47 is greater. So our critical part is A, B, D, F and H. Now once we do that, so we are done with network and find the expected time and variance. And now we need to get the, okay, along with the standard deviation. Okay, so we need to find probability. Now in order to find probability, we need to first find standard deviation. For that we need to find variance of the critical part. Our critical part is A, B, D, F and H. So A, B, D, F and H, these values we'll have to take it. Okay, so variance of the critical part will be 16 upon 36. So I'll just take it as see A, B, D, F and H. So 16 upon 36 plus 100 upon 36 plus 256 upon 36 plus 64 upon 36 plus 4 upon 36. Okay, that would be a critical part. Add up the numerator, keep the denominator as it is, divide, we get 12.26. When you remove the square root of that, we'll get a standard deviation of 3.5. Now so this is standard deviation. Now they are told to find the probability for completing a job in 55 days. So time that we want is in 55 days. Z is equal to TE, or you can use the alphabet X also. Okay, minus the critical part upon standard deviation. When you divided minus it divided, we got the value of 2.29. Now this is the Z value. We need to check in your table. So check in the Z value our table. So table value will come approximately 0.4890. So find the probability that the work should get over in 55 days will be 0.5 by default plus 0.4890 that we just found. We add up, we got 98.9. When we add up the total, we come to and multiply with 100, we'll get it into 98.90%. So the probability of getting the job done in 55 days is 98.9%. Okay, so this is how you'll have to solve the sum based on PERT analysis. Okay, this was question number 3B. Now let us check which was the next question. I hope everyone have understood this. The next one was question number 3C. Okay, they are giving you jobs and person and they're asking you to optimal assignment, and is it a case of alternate optimal solution that they have asked us to find. Okay, they just ask yes or no. Okay, so in that case, first step will always be we need to first check 1 2 3 4 5 and 1 2 3 4. So it is a unbalanced problem. We need one dummy. So we'll have row mein, 1 2 3 4 5 and 1 2 3 4 5, where the last one will be called as dummy. The step number 1 is always row minima. So from each row take the minimum value and minus it also. 18 is the minimum, so 27 minus 18, 18 minus 18, 20 minus 18, 21 minus 18. Same way in the next row 12 is the lowest, so 12 minus, all the numbers minus 12. In third 16 is the lowest, so 16 minus all the others. And in the last again 16 is the lowest, so all number minus 16, we get row minima ka table. Now and last made is zeros. Okay, that's the dummy, so everything remains same. Next we need column minima. Now in each column minima, since all the columns there are zeros, so all the values remain same. Once we do that, then we need to start crossing the line. So wherever maximum zero, so we have one line, we have second one, we have third, and we have fourth. Now there are 4 lines and the matrix is of 5 by 5. So it is not an optimal solution. We'll have to make it optimal. In order to make it optimal, the rule is from the unmarked, the uncrossed, which is the lowest value. 4 is the lowest value. So all unmarked minus 4, and wherever it got intersected, there it will get added. So a new table will look something like this, where we have all other values. So this 9 became 5, 19 became 15, 4 became 0, and where there were intersections, okay, they got added with 4. Okay, so those all value got added. Once we get that, again we started crossing. So our first cross, second, third, fourth, and fifth. There are 5 lines. So 5 by 5 it is. So we have assigned it, we have optimized it. Now we need to get the marking of zeros. So 0 mein this was the only 0 first. Okay, then here it was the only one second. Now in this column this is the only one available. So we mark this, so this get crossed out. Since this and this got crossed, okay, this is also crossed out. So the only one remaining here is now this one and 2. So this is it. These are all 1, 2, 3, 4, 5, all on different columns and different rows. So this is our optimal solution. So project P1, P2, P3, P4, P5, J2, J4, J5, J3 and J1 were selected. The cost of which from the original questions are 18, 12, 16, 20 and 0. Total of which comes to 66. In case, is it a case of alternate? No, there was no alternate availability here because all other things have been marked out. Okay. So this is how you all had to solve the sum based on question number 3C based on assignment problem. Okay, I hope everyone have understood it. Next one, last question, question number 3D. This was based on game theory. So game theory is very simple. First, you note down the same table as it is. So we have noted down. Next, we need to find something called as row minima. So from each row, the minimum value, so 28, 45 and 50. And then column maxima. From each column, we need the maximums, so 75, 52 and 50. Then we need to find maximum. From the minimum, the maximum value was 50. And from the maximum, we need to find the minimum value, which is again 50. So 50 is common in both. That is nothing but our saddle point. Finally, we just have to show optimal strategy for Laco textile will be, for Laco, it is the third one which was selected. Okay, third one, which is heavy advertising. So heavy advertising is selected. So my optimal strategy will be 001. Same way for rayon textile, the third one got selected. That is again heavy advertisement. Okay, which will again be 001. Saddle point is 50. Therefore, the value of the game is also 50. Okay, so this is how you all had to solve on question number 3 under this particular question paper. So I hope everyone have understood that. So with that, we will be ending this video here. Thank you.